axes, the expanding surfaces, and in particular, I would like to talk about this curve inequality. So if I fix my R, okay, so if I fix my R, so these animations are good actually. If I fix my R, imagine my fixed R is 5 actually. Okay, so I just fixed it to the value 5. And I allow theta to be anything. So if I'm variating Z, so what's going to happen? So it's like if Z is going up and down, so it's like this, the height of this plane is changing actually. Okay, depending on. And if I'm variating my angle theta, what happens is that basically, so it's like, it allows it to move in circle the plane actually. And you can imagine that when this plane is going to move out, it's going to swap out a cylinder actually. Okay, for each value of theta and Z. Each value of theta and Z. Are you getting the point? I can do also the same thing. I can say that, okay, let's fix angle theta and change the radius. So if you're going to change the radius, what's going to happen? Okay. So somehow this radial distance is getting changed. And by changing Z, I'm changing the height of this plane actually. And similarly, I can say that, okay, if I fix Z, and I, variate R and theta. So if I variate R and theta, you can have, so it's like, you can have a cylinder, but this time I'm not changing the height of the cylinder, but the radius of the cylinder. Okay.
Slicing it through.
Yes. And now if you want to see all this together, so it's something like this. So this is what you call kind of a moving picture of it. Okay. So it's like R and theta and Z, all three are changing simultaneously. So this is what is happening. So you have a cylinder, so it's like, it grows up. Okay. So it kind of shows that you have, your R is changing, and okay, so you have this plane moving, in circles. This kind of shows that your theta is changing while you have this.
So R is
Yes. So R is the radius of the cylinder, and it's changing. If you fix it, then you have a fixed cylinder actually. Okay, so you get a fixed cylinder. So that's what is actually the point. Are you getting the point? Now here is the fundamental question. If I want to change or measure the change in each of these directions actually. So I want to measure, how much of this cylinder is expanding and how much of, this plane is, moving along, okay, in circles, and how much of this plane is going up and down, okay. How can I do it? So in order to do so, I need 3 vectors. So one unit vector in the direction of radial direction which is going to essentially measure that how much of the radius is changing actually, and the other vector. Okay. So one vector would be giving me description in the change of in the direction of radial change. The other would give me, so if I fix a point actually, so kind of describing the change in z-axis, and the other is going to be in the direction of theta actually. So you have to keep this. So what is the